Welcome back. Okay, I hope you tried to solve the exercise. Now I'm gonna solve it without using the cool features of Go that you didn't learn about yet. Normally, I would do this in a different way. However, at this level, it's better to use the features that you learned so far. Alright, let's get started. Let's add the second username and the password inside the constant declaration here. I'm gonna add one more user constant here. User2 Inanç. Then I'm gonna add the password constant for the second user. Pass2 1879. Okay. In this if statement, I need to check the username of the second user like this. U not equals to user2. Okay, so if both usernames are not correct, then it will display an error. Otherwise, it will execute this else if branch here. This means that both usernames are correct. So here, I'm gonna check whether the second password is also correct, like this. P not equals to pass2. Here I'm simply telling that don't grant access if both passwords are not correct. Okay, let me try this. First, I'm gonna pass the username and the password for the second user. Inanç 1879. Cool, it works. Now let me try the first user's password instead. Let me delete this and let's type 1888. This also works, right? But it shouldn't have worked. It's because now the second user can access to the system by using the first user's password. It's like you're accessing your email application using another user's password. And they can also access yours by using their own password. So this is not good. Let's fix this now. Okay, the problem is in this line. So it doesn't matter which user's password I'm passing to the program. This just checks whether the passed password matches to the first user's and the second user's password. So that's the problem. To solve this, I need to add another condition to this bool expression. For now, let's remove the second check from here. Okay, so first I need to check for the first user, like this. U equals to user. Then let's make this more simple by changing this not equal operator to equal operator like this. Since this last expression checks for the correct user and password, so I need to move this access OK from here to here. Then I also need to move this error password from here to here. Okay. So here, first this checks for the first user. And if it's the first user, then it checks for its password. So if the user is the first user and the password is the first user's password, then it grants access. Now let's add another check for the second user this time. First, I'm gonna type a logical OR operator. Then in a new line, I'm gonna check for the second username, like this. And if it's correct, then I'm gonna check for the second user's password, like this. So here, if it's the first user and its password is correct, or if it's the second user, or if its password is correct, then the program will grant access. But if neither of them is true, then it will execute this else branch and it will say that the password isn't correct. Okay? As you can see here, when you end your line with an operator, then you can type the second expression just below it. Okay, let's try this. First, let's try it with the first user, Jack. Then let's use the second user's password, 1879. Cool. This time it didn't grant access. As you can see, now I can't use the other user's password. Wow, security improvement indeed. Okay, now let's type the correct password for the first user. Access granted. Cool. Now let's do the same check for the second user. Let me pass the second username with the first user's password. It shouldn't work, right? Alright, it didn't. Good. Now let's type the correct password for the second user finally. Access granted. Good. Okay, so far so good. However, this code looks somewhat ugly, right? This bool condition looks complex to me. Let's make it simpler. I'm going to add another else if branch here like this. Then I'm going to cut this bool expression from here. Then I'm going to move it here as the condition for this else if branch. And I need to remove this logical OR operator as well. And lastly, I need to duplicate the access granted message for this else if branch. Okay, I think now it looks better. I needed to duplicate the access granted message, but that's okay. Sometimes for more readable code, you may need to duplicate the code, okay? Normally, I could do this using a function, then it wouldn't be duplicated, but you'll see how to do that afterwards. Okay, let's try it one more time. Let's try the second user with the first user's password again. It shouldn't work. Good, it doesn't work. Now let's type the correct password for the second user. Access granted. Okay. Now let's pass the first user with the second user's password. Cool. It doesn't work. Now finally, let's pass the correct password. Okay, access granted. Cool. As you can see, else if branch here acts like a logical OR operator, right? So this code and the previous code acts like the same. Alright, that's all for now. We built a user password protected command line program, military level security indeed. I'm just kidding, of course. Okay, you should be proud of yourself. Thank you for watching. See you in the next lecture. Bye bye. Welcome. Let's talk about the nil value. Nil is a predeclared identifier just like the other predeclared identifiers such as true, false, lamp function, int, float64, and so on. So it can be used everywhere without importing any package. It simply means nothing or something undefined, uninitialized, and so on. Let's take a look at how it's called in other popular languages. For example, in JavaScript, it is known as null. Or in Python, it is none. In Java, it is null. And in Ruby, as in Go, it is nil as well. So if you know about at least one of those languages, then you already know what I'm talking about. But if you don't, no worries, it's actually a very simple concept to understand. It will especially be crystal clear, and I'll be talking about the pointers afterwards. Basically, nil just means that there is no particular value exists. But nil itself is a value. It's a special value which says that there is no value. You know already that in Go every uninitialized variable gets a zero value, right? The zero value of all the pointer-based types like pointers, slices, maps, interfaces, and channels are nil. That means values belong to those types are not yet initialized to some prepared value. In Go, a nil value can be untyped and typed depending on the context. You'll see about that later. You'll also learn about those pointer-backed types afterwards. However, it is good to know now when nil is used for. Okay, in Go, nil value is also extensively used for error handling. For example, let's say that a function returns an error value. I'm going to talk about what an error value means in the next lecture. So when you call that function, and when it returns a nil value as the error value, then it means that there wasn't an error and the function call was successful. Or if the error wasn't nil, then it means that there was an error. To understand what I mean by this, let's take a look at a simple code snippet here. As you can see here, I'm calling a function named do, and it returns an error value, so I'm saving it into a variable named error. So what should I do with this error value? Let's check it out. Here I'm just saying that when the error variable isn't nil, then let's run the code inside the if statement here. Let's say that the error variable wasn't nil, so the code inside the if statement will be executed, right? This means that there is an initialized value inside the error variable because it wasn't nil. The do function here has initialized that error variable with an error value, and then it returned it. So since there was an error, this means that calling the do function wasn't successful. Okay, it couldn't do its job. There was a problem. That's why it has returned a non-nil error value. So if that's the case, then I need to handle the error right inside the if statement, okay? Then maybe I can log that error or I can terminate from the program. Otherwise, let's say that the error variable was nil. So that means there was no error. Do function was successful, so it returned a nil error value. This means that I can continue executing my program because there wasn't an error. So in summary, when there is an error, you should always handle it. One common way of doing it is just by using a simple if statement as in here. Then you can take proper actions. For example, you can terminate from the program. Or if there wasn't an error, you can happily continue executing the rest of the statements in your program. Alright, this was a quick introduction to nil values and handling errors in Go. It's very normal if you don't understand it now. But with further examples, nil and error handling will be much more clear. No worries. In the next lecture, I'm going to talk about error values and how to handle them using a real-world code. Thank you for watching. Bye-bye. Welcome back. In this lecture, I'm going to show you how to handle the errors with examples. If you're coming to Go from other languages, you may be surprised that Go doesn't have throw-catch statements or exceptions in the usual sense. As I showed you in the last lecture, we Gophers use a simple if statement to check for the errors explicitly. It's because it's more readable and bugs cannot hide under the buggy code or inside a throw-catch statement. Let's check it out now. In Go, some functions always work without any errors. For example, let's take a look at the i2a function from the strcount package. You've seen it before. It just takes an int value as an argument and converts it to a string value, then returns it. Okay? This function always succeeds and it never fails. It's because an integer can always be converted to a string value, no matter what. There is no need to return an error from this function. So since this function never returns error values, so you don't need to handle any errors when you call it. Okay, now let's take a look at an example code to understand this better. Let me call strcount.i2a by passing it an integer value like this, 42. Okay, I'm gonna save the result of this function into the s variable, which is a string, since i2a function returns a string. Let's take a look at the documentation of this function again to better understand how it works. As I showed you before, it takes an int value as an argument and returns a string value back. Okay, it's that simple. Alright, let's print the result now. Okay, let me run it as well. As you can see, it just prints 42 as a string. Nothing interesting here so far. But now you've seen that you don't need to handle any errors for this function, because it doesn't provide any error value for you to check. It always succeeds. Now let's take a look at another function which returns an error value. Here is another function from strcount package. A2i means ASCII to integer. You can think of ASCII as a string value. So it takes a string value and it tries to convert it into an int value. Pay attention to my words now. It tries. So it doesn't always succeed. As you can see here, that's why it also returns an error value. That error value tells us about whether the conversion from the string value to int value is successful or not. As I said, this function doesn't always return a successful result. It may fail. And when it does so, you should never use the returned int value from this function. It's because the returned value may be in an undefined state. It's probably gonna be a value which you didn't expect. But in the case of A2a function, it returns 0 as an error. So it doesn't matter actually whether you check the error or not. I'm just showing it to you here as an example for handling errors. It's just a simple example. Okay, now let's take a look at its error value. When it returns a nil error value, it means that the function is successful. So you can use the converted int value, okay? Otherwise, when it returns a non-nil error value, it means that the conversion has been failed and it couldn't convert the passed value to an integer. Let me show you this function in the coding editor as an example so you can understand it better. Let's first call the a2i function like this. And let's pass it a command line argument. As you can see here, it returns an int value and an error value, right? So let's assign these values to variables. I'm going to store the returned int value in the n variable. Then I'm going to store the returned error value in the r variable. Okay? Alright, let me print the returned integer value as well. Println converted number. I'm going to pass the n variable here. Okay. Then let's print the returned error value. Returned error. I'm going to pass the error variable. As you can see, I can print the error value because in Go, errors are just values. Okay, this is important. If something is a value, then you can use it almost in everywhere because it's just a value. Okay, now let me run it. First, I'm going to pass the correct number, 42, like this. Notice that it has returned nil here. Remember, this is the returned error value. So now it's nil. So this means that the function has been successful. As you can see, it prints 42 here. So the conversion was successful. Remember, a2i function can only convert a string value, which contains a correct numeric value. So now I'm going to run it with a non-numeric value, so it will fail. Look at what it returns. It has returned 0 here, because it has failed. As I said, you should never use the returned values from a failing function. And it has returned an error value. As you can see, error values can print themselves. Here the error value prints itself like this. So in summary, when a function returns an error value, you should always handle it. And when there is an error, you should never use the rest of its result values, except the error value. Alright, that's all for now. Congrats, now you know what an error value is. In the next lecture, I'm going to show you how to handle the returned error values. See you there.